presentation.
Kasi may mga questions last week na hindi mahirap i-explain pag walang figures. So gumawa ako ng figures para ma-explain parang maigi. Okay.
Ayun, maganda to sir. Mukhang magandang presentation ngayon. Naka-ready talaga.
Oo, kasi last week yung may mga questions na hindi ko masyado ma-explain pag walang figures. Iba talaga.
Maganda yan sir. Maganda itong topic ngayon.
Okay. Okay. Sige, start na tayo Okay. Last week, there were a few questions wherein I tried to explain, but it's really hard to, discuss without figures. So I'm trying to reproduce some of the questions last week. So one of the questions was, why is there a seismic load at the tie beam? I'm not sure who asked this, but the answer to that is, as you can see here, if you have a simple frame, now actually in your model, only the support or the footing won't move. The rest, say for example, like this, even all the beams, including the tie beams, should move because tie beams are not restrained laterally. Okay, so that's why these equivalent lateral forces must also be present at all nodes that move. So that's the main reason why there is a very minimal seismic load at the location of the tie beams. So do you understand now? Do you have any questions? Why? Do you have any questions to this explanation? Okay. So another question was this one. How to create a curved beam or element. Now, I'm going to share with you some of the models I did here. I think you're familiar with this Sydney Harbour Bridge. Okay. Now, you can see there is a curved members in the bridge. So what I can share with you is this is the model I created. Okay, now you can see here I have this I have this mahina mag okay, see here these curved elements at the top were actually modeled using I have to view elements. See here. So to model curved beams is just to divide the beam into small segments. But you need to have the coordinates of every end node of each segment. So that's the way how to model a curved element. I also even modeled this one. See here, I was able to model a letter C by dividing this letter C into see here, what I did, I divided the curved portion of the letter C into several segments. So if you have a curved element, you can divide that into small segments, and it's up to you what length are you going to use with that segment. So the smaller the segment, the accurate is the curvature of that curved element. So basically, that's the way to model curved elements or beams. Okay. So see here, okay. Now, another question last week was this one. What is two-way slab and one-way slab? Because what we learned in our college days is that if you have a slab that is less, if the ratio of the length and the width is less than 2, it is two-way slab, and then if more than 2, it's one-way slab. But that's not really accurate, because what makes a slab one way is how you design or reinforce your slab. Say for example here, if you have this rectangle, it's actually, we can say this is our two-way slab, but I can design this slab as one way by designing the slab reinforcement only having a one-way direction, and I can just have the reinforcement in perpendicular, just the temperature bars or minimum reinforcement. So in this way, I am designing the slab as a one-way slab, even if it's near square. And if it's two-way slab, then I have to design the slab reinforcement in two-way. So the disadvantage of one-way slab is that you will have a thicker slab in one-way slab, whereas in two-way slab, your thickness is smaller than the one-way slab. But basically, it's up to you. How do you design the slab? You can have it one way or two way. It's up to you. It doesn't matter what the dimension is. Okay. So next question, this one. Now there was a question today. Somebody was asking, why is there no undo in FrameCE, but there is undo in AutoCAD? It's like saying, why there is reverse move in cars but not in airplanes? Basically, it's like that. The reason is that if you have undo in FrameCE, it's very risky. I can again create an undo button, but there is a reason why I don't want to create an undo button. Say, for example, when you divide an element into segments, what you're actually doing is not just dividing. you are also creating elements, and by dividing the elements, you are also creating nodes. You are also declaring releases in each new node. You are assigning zero loads at all nodes in all directions. You are assigning zero loads in element loads. So many things are done when you create or when you divide an element. So that's why it's very risky if there is an undo, because you don't know what is going inside. So what you can do instead of undo is just delete or edit. So anything you want to undo can be done either by delete or edit. So there's, and in this way, you are sure that you know what you are doing, and there's no hidden steps there, because you know what you're deleting and you know what you are editing. You can see it. Unlike in AutoCAD or drafting, where you undo, you know that the line is undone, but it's only line. Okay, so I think that's all. That's all what I need to explain. Now, then I will create a new project.
Sir,
Sir, okay? Yes?
uh, can you please discuss the brief kanang the seismic hazard, what was that? Seismic hazard analysis.
Analysis?
Yeah. Can you please have a slight discussion,
Okay.
background, just background?
But until here, do you have any questions? Do you have any questions related to last week's presentation? No? Okay, so we'll go to actually, I'm not sure. I think somebody's project is this. Okay, now seismic hazard analysis. This one. Now, actually, seismic hazard analysis is not really useful in structural analysis at this time, because it's more on the risk of the structure, not related to design, but it's more on the risk of failure. It's not at this time. It's not yet directly related to your design, but I can discuss this if you want. Now, in seismic hazard analysis, sometimes when you design a structure, there's a requirement of what's the possible magnitude that structure will encounter after 50 years, 100 years, 500 years, or something like that, or 1 in 500 years. Now, the answer to that is nobody can tell what's the exact magnitude or what's the exact peak ground acceleration. But what you can say is that there is a risk of, when you say risk, there's a probability that you can have that specific value, but it's not 100% sure. You only have a certain or probability. That's why you need to have a seismic risk analysis. So say, for example, if I have a structure in, say, for example, Cebu City, okay, then I click this Cebu City, and then because Cebu City is quite large area, So you need to be very specific on which location or which. Okay, now, okay, here. Now, see, for example, I want to know the seismic risk in CIT. So I have to find, where is CIT here? Ayala Center. You can see there's a cursor. You can see here there's a red cursor. So this is your location. Okay, so I can zoom. Okay. So I have to find. See, is Cebu City National. Okay, here. Here. Okay, here. Ikaw may nag-request ini, Carl, no? So, CIT man kasi CIT lang sa itong kanon ini. Okay, see here. The cursor is centered in CIT. So you can see the latitude and longitude of CIT is here, 10.29. Longitude is 123. So every time you move the cursor, the latitude and the longitude also changes. Okay, so now once you have the latitude and longitude, you can click this PSHA, meaning probabilistic seismic hazard analysis. So you click this button. Okay, here, now see here, it says longitude this one, latitude this one, and this is the expected magnitude with a return period of 475 years. This is and the magnitude is 5.7, the hypocenter is 18.77, and then this is the simulated response spectra, and this is a simulated ground motion. Now you might be wondering, where did I get these values? How did I arrive at this response spectra and this simulated ground motion? Actually, my doctoral dissertation is on this topic in probabilistic seismic hazard, and I have also a paper which shows how the equations were derived, all these equations, all equations that were used to arrive at this ground motion and response spectra. Now, so if somebody will ask you, what's the return? What is the expected magnitude with a return period of 475 years? So you can have these values. Now, there's also an option of having more than one simulations. See here, I want 10 simulations. Now, if I do 10 simulations, you will expect. Okay, I have to wait until the simulation is finished. Now, see here, the response spectra becomes more and more smooth. The reason for that is FrameCE average, the simulation averages all the 10 simulations. That's why the response spectra becomes smooth, because this is the average. And the more data or the more simulations you do, then the smoother is your response spectra, because this is the average response spectra. So if I just do one simulation, it's you can see here it's not as smooth as having 10 simulations. Now another one is that you can also produce a report. See here, if you okay, and then I'll type CIT. CIT Cebu. Okay. I think I think he hung up. Ano ko? Can you hear me?
Yes, sir. Yes, sir.
Kay mura bang niya ang computer? I think I have to again. Okay, good. Okay. Okay. Exit. And then I think there is a report. I'm not sure if okay, I think the report, here. See here, FrameCE will also give a report on probabilistic seismic hazard in PDF. So this is the output of the report. Okay, so basically it's not really useful if you are a structural engineer, but it is useful if you are doing some risk analysis. Okay, now until here, do you have questions?
Thanks, sir.
Okay, so can we proceed to another topic?
Yeah.
Now, okay, next one. What? Okay, analysis. Member. Okay, I'm going to use this. Who's this? Hi, Mark. Is this your project, Mark?
Yes, sir.
Mark?
Yes, sir.
So can I use your project as an
Yes, sir.
example?
Why problema, sir? Sige, salamat.
Okay. So kapoy na kayo mangitagain ba? Maghimo ba? Okay. Okay, I'll just use Mark's project. Okay. So I think Mark is earning quite. I'm not sure how much did Mark earn for this project. So okay. See here. What I need to do here. What material? Okay. What? Okay. Now, I want to analyze this. How many? Oh, 2 minutes. Now, I think I don't want to use this project because there are so many loads and it takes so much time. I'll just use another project. It takes time. It takes time. Okay, I'll delete this. Now, I have a slab. First, I will create a slab because I don't have one. Do I have slab here? No, I don't. So I will create a slab first. And then I send this. Okay. First, I will create a slab load. Okay. Exit. And then we live load. I'll create. Okay. Okay. Now, what I need to do here is to analyze. I will analyze. So there are two ways of analyzing. You have here a linear and a secant order. Now the difference, this secant order is not what you think as non-linear. It's not. It's just what you call as considering the P delta effect of loads. So this is not secant order. This is not the non-linear. Just a P delta effect. Okay. So first, if I to analyze the structure, you have just click this linear analysis button or this one. Okay, so I'll go for this one. Okay, now if you want to know the actual, this one. And I have the option. There, you have the option of having the stresses or member forces displayed as a stress contour or color contour, or as like a graph. But when you have more than 50 elements in your model, then automatically FrameCE will only use this color contour. Okay, so you can just click. This is the X displacement, the Y displacement, Z, the major axis shear, the minor axis shear, the torsion, moment, major moment, minor, like that. Now, somebody might be asking, I want to know the shear and moment diagram of a specific element. So what you need to do is click this diagrams button, and then click that, and then select an element. See here, if you select this element, what you can see is the shear diagram, the moment diagram, the displacement diagram, as well as the axial forces in that particular member. Okay, so this will also tell you if the axial is compression, then it will display C, letter C. If it's tension, it's letter T. So basically, you can identify all the member forces by just clicking this member forces diagram. And currently I am in dead load. So if you want to go to live load, then go to live load, and you see here all the diagrams are now for live loads. Okay, so I'm going back to did load, like that. So this is the way to do. This is the way how to view your shear and moment diagram. Okay, if you're finished, just click the. Oh, by the way, this is for major axis. You can also have the member forces in the minor axis. See here, it's basically 0 because I haven't applied load in the minor axis. Okay, so back to major axis. If you're done, click the close button, and you're back. Okay, so next, if you want to say, for example, I want to view the moment diagram. Now, if you click this show maximum button here, FrameCE will show. I will hide the diagram, the loads, the slab graphics. Okay, here. Now, when I click the show maximum diagram, I have here 2 elements colored black. These 2 black members are actually the member that have the maximum moment. Now, there are 2 black elements because both of these elements have identical maximum moments. Okay, so in shear, for example, in shear, 4 elements have the same maximum moment, maximum shear. For displacement, this one, the top 2 elements have the same maximum Y displacement. So it's very easy for you to identify which elements have the maximum force. Okay, so you can turn this off. Okay, this one. So you can also export the analysis results by clicking this Excel export button. If you click this, FrameCE will ask you which element will show the printout. Now, I did this because sometimes you have lots and lots of elements, and you don't really want to know all stresses of those elements. Sometimes, or most of the time, you only need to know the stresses in the few elements that have the maximum forces. That's why there is an option which element to show the analysis results or to print out. So I will select yeah. See here, I'll go back to, I have to turn this off. Okay, analyze, I will go back to, I will analyze again. Okay, and then select members to show. I will select a few, maybe these columns too, and then okay. And then see here, the member forces for the elements which I selected are displayed here, exported to Excel for all load cases here. So until now, is there any question? Do you have questions until now?
Sir, doon sa pag pwede tayo makapili kung aling load combination lang ang i-print ni Excel.
Hang on. Load combination at this time, no. You have the option of which element, but we can do anything. I mean, maybe later I can do that, but it's not a problem.
Okay,
But at this time, no.
Okay, sir. No problem, sir. Okay. Okay, thank you.
Okay. Any questions? Wala bitaw bayad. Okay, I think it's very simple. And I try to make FrameCE as simple as possible in everything you do. Okay. So next, what else?
Sir, question, sir.
Okay. Yes.
Sir, if let's say you have different load combinations, can you take the maximum from all the other different load combinations, or could you have an sort of an envelope stresses?
So okay, I will rephrase your question. Can I get the envelope stresses for which element?
Let's say in one in a certain model, let's say one element has the maximum if the combination is dead load 1.2 dead load plus 1.6 live load, but in another load combination, another element is also having the maximum. So how do you analyze that if you are going to design the whole structure using all the load combinations?
Okay, I got you. So that means you are designing the element using your own template, not FrameCE, because FrameCE does it automatically. So I assume that you want to design the elements using your own design program or design template, right? Because FrameCE can do that automatically. Okay. Now that's okay. I will show you how. First, I will create. Okay. I will create different load cases. Okay, so first load case combination, say 1.2 D plus 1.5 slide. Okay, 1.2, 1.5. Next, I will create another case, say D plus live. And then I will create another one. Say today. And then I'll make the loading more non-uniform to have different maxima. Okay, load edit. Okay, this one I will make this as 20. And then I will make this as 50. Okay, and in live load, I will make this edit 55. And then I will hide the loads. Okay, so I will analyze. Okay, so for example, for load moment, okay, moment for load case combination 3, the maximum is this element. Okay, now for load case combination 4, still I think the load maybe the load is not so. I will add another load. I will change the load because they have the same. Okay, sorry.
Naka-zoom in man ang kan.
I will change the loading. Maybe I will change the loading because they are not. The load doesn't show variety. I need to edit the values. Okay. Okay. Next, I will edit. And then edit. This is maybe 15. Okay, I'll change the
Okay ba?
okay, here. Now, I will analyze again. The media moment maximum. So okay, now see here. For example, in load case combination 3, you can see the maximum is this element. Now you can, and then you know the values because the values are indicated here. Okay, then go to the next load case. You can see that these two elements are the same. And if you go to another load case, you can see this one. So basically, if you change between load cases, you will know which element has the maximum load. And it doesn't have to be the same element. It can differ from one load case to another. So I'm not sure if I did answer your question, Yuri.
Yes, sir. You answered the question, sir. But I was just asking if pwede ba siya ma-import ang katong Excel file na siya but the maximum na ang makita dili per load combination.
Maximum. So does it mean that only one element will be displayed because the others are not maximum? Do you mean that?
I think what
maybe only few elements will be shown, sir, showing the
Okay, yeah.
maximum of the load combinations.
Okay, now you can see here. Okay. Okay, now if I export the element, right? If I export the street the member forces, I have the option of which element to show analysis results. So if this element gives me the maximum, then I can only show the stresses in this member. You see here? Okay. Did I did okay, and then I'll get to Excel. Oh, it gives error. Okay. I'll save first. Did I? Save. I'll save. Okay, and then I'll do again. It gives. That's why. I know the reason now, because
Close mo lang sir yung Excel.
yeah, that's right. I was wondering why. I think you're good now, Ali.
Yes, sir.
Okay, now I'll run the analysis. Okay. Okay, so maximum. Okay, the maximum is this. For load combination, this one is the maximum. So what I will do is export the members, the member stresses, and then select this element. Okay, and then see here. I only have member number 45. I only have member number 45 because this element is actually member number 45, I think. Yeah, see here, this element is member 45. So that's why the result only showed the number 45 element. So does this help, Yuri?
Yes, sir. Yes, sir. Thank you so much, sir.
Okay. Yep. Okay. So, any other question? I think I think FrameCE is really easy. It's very simple if you have just tried it maybe a couple of times. You will see it's the easiest software you can use, because there are not so many buttons, not so many menu, but you can do almost everything.
Agree, sir. Agree.
Say, okay. So, what else do you want to know?
Who are you talking to?
Okay. So, what else? I think I'm not sure. Okay, design. Let's go to design. Okay. Now, when design. Okay. Now, if you want to design, go click the design button, and then you have the option of designing the members individually or designing the whole structure automatically by FrameCE. Now, first, what I want to do is to design each member individually. Okay, so once you are in design menu, you have the option of linear or second order. So I'll just show the linear because it takes a bit of time to explain what this second order is. So I will start with linear elastic, and then FrameCE will run. Then next is you have here select load cases to check for strength design. Now, if you want to design a member, obviously you have to specify which load case you want to use. You don't need to specify all load cases, obviously, because some load cases are for displacements or serviceability. So say, for example, I want to use these two load cases, 3 and 4. And what this means is that FrameCE will check only the stresses from these two load cases, cases 3 and 4, and then click OK. What I mean, next is what I mean. Okay, now it's okay. Now, actually, if you haven't declared the rebar sizes to use, FrameCE will ask you what rebars. But this is a project which I have already done. In which the rebar sizes were declared. So FrameCE is no longer asking me. So once you have declared the load cases, then select an element. Okay. Well, you can select 1, you can select 2, you can select 3. Now the difference of this is that if you select 3 elements or 3 beams, then FrameCE will just design 1 reinforcement for these 3 beams. That means you will have conservative design because not all these 3 members don't really have the same member forces. So just for the sake of demonstration, I will select 3 elements. Then after that, click this individual design button, and then now it's here. After I did click the design button, FrameCE asked me what reinforcement should I use. Now I think this is useful because sometimes you don't have all sizes available, so you can choose which size you want to use. And this is also the request of GR Prudenciano, that he wanted me to specify if in beam design there should be an option if you want to use the moment at the face of the column or at the center of the joint. So if you use the face of column moment, so obviously you will have smaller moments. Okay, so I will use the face of column moments, then click OK. Okay, yep. Now FrameCE is checking the 2 load cases that I used, and also checking the stresses for the 3 beams that I designed. Okay, so see, see here. So this is the recommended design from FrameCE. Now what happened is that FrameCE will first assume the initial size of the beam similar to the model. So my model used the same size for columns and beams, so it's 350 by 350. So that's why FrameCE also used this size. So if you like the design, you can click this accept button. And if you don't, then FrameCE will just ignore the design. So I will click the accept button. Accept. Now, what you notice here is that the color of these three beams changed to gray. What this means is that if the beam is colored gray, this means that it has been designed. So you already have the reinforcement of this. Whereas these non-gray elements, meaning they still have to be designed. Okay, so that's the difference. Now, next I will design the column. These two columns are just one column, for example. And then click individual design. And you see here, you don't have to declare that a member is a column or a beam, because FrameCE can tell if it's a column or a beam. So automatically FrameCE will just open the column template if it's a column, and open the beam template if it's a beam. Okay, see here, this is the recommended design of the column. Now, there is a difference between how FrameCE designed the column and a beam. In FrameCE, in beams, FrameCE will start with the initial size similar to the model assumption. And then if the beam is still not safe, then FrameCE will increase the depth. But in columns, FrameCE will not change the size of the column. It will only design the reinforcement. Now, if the reinforcement reaches the maximum ratio and still the column is not safe, then FrameCE will warn you that the column is not safe. Then you have to increase the section size in your model. Now, I did this because usually column size in actual construction is more restrained in terms of size. We cannot change the column size all the time. Unlike in beams, it's easier to change the beams because there are you can hide the beam sizes if there is a ceiling. You can see so that's a difference. But columns, no. It's usually the architect will complain if you have columns larger than what they want. Okay, so you can see here that this the column the color changed to gray because this has been designed. Now, see, for example, I will design this beam here, and then okay. Now, see, this is the design. Now, if I don't like the design, then I will click this I don't like button. And then what happened is that I think, I'm not sure. I think maybe this was designed, but anyway, I think they shouldn't turn to gray, but I will check. But did I? I'll check again. I'll try to design this one. Design. I don't like. Okay, I think I should change FrameCE because even if I did reject the design, the color tone to gray. So I think I should edit this one. This shouldn't tone to gray. Okay. Now, this one of the discovery in this this decision. Now, until now, is there any question? Do you have any questions?
Sir, footing din, sir.
Okay, footing. Now, so beams and columns are very easy. So actually, somebody asked me if I can discuss on how to design FrameCE, and I told him that I should discuss more on how to model, because there's nothing much to learn about designing. It's only just clicking of a button. So what you need to learn is how to model, not to design FrameCE, because everything is automated. Okay, now design for footing. Okay, now see here, just click the footing. See here, and then FrameCE can tell that it's a footing. You don't have to tell FrameCE. Okay, now, and then click individual design. Okay, now it says here, declare the ultimate swell bearing capacity. Now this comes up because I haven't declared the swell bearing capacity yet. Now that means I need to declare the ultimate swell bearing capacity. Now, one thing you should be aware of that of this is that this is the ultimate bearing capacity. This is not the allowable bearing capacity. So this is the factored capacity. Okay, so this is higher than your allowable bearing capacity. Say, for example, I'll say 250. Okay, and then now also in footings, FrameCE will start from us like one by one dimension, and then it gradually increases the size until it is safe. Well, at this time, FrameCE only design a square footing. It doesn't design rectangle or any other geometry. But there is a template where you can design a rectangular footing. So I will accept this. Okay, this one. See here, I have designed the footing. Now, next is what else? Say, for example, I want to stop my design. So what I need to do is click this back to model button. And now I'm back to model. Now you can see here, oh, the footing in these two footings are actually much bigger than the rest. It's because this is the actual size of the footing I have just designed. This is now the accurate plot of the three-dimensional elements, including the footing. While these 6 footings are still have to be designed. Okay. Now, if you click this design results, and then FrameCE will tabulate the designs. Okay, see here, it will tabulate the beams. I only designed 3 beams. These are the members 12, 13, 14. So that's why only 3 beams are tabulated. You can see here that the end node reinforcement, the mid-span reinforcement, and the other end node reinforcement are tabulated here. And FrameCE also gives you the concrete volume in each beam as well as the estimated reinforcement in kilograms. And this includes the mean bars and the stirrups. So this is just a rough estimate. You shouldn't be too dependent on these values, but this is much better than nothing. Okay. Now for columns, I only designed one column. That's why the result also shows only one column. And again, it gives you the dimension, the width, the depth, the number of bars, the bar size, the tie diameter, the spacing, and the concrete volume, as well as the rebars. Okay. Now the footings, I have designed only 2 of them. So there are 2 footings that are tabulated here. So if you design all of the members, then you will expect that all of these members are tabulated. Okay, so until now, is there any question?
Sir Rib,
Yes.
sir, can we design a footing that is not concentric, or the column is not located at the center of the footing?
Right. No, at this time, no, not in FrameCE. No, it cannot. This time. So I think it's very easy to develop a template for that, and I really encourage everyone to develop your own template in as much as you can, because design is not really code, or I mean, you can have different designs based on what you want, on what you need. So design shouldn't be the same for everyone. That's why it's called design. So any question until here? Okay. I have to see this one. What happened? Can I save this as my? I will post it in Facebook. So is it okay? Can I post your face here in Facebook, Ali? In Facebook.
No problem, sir.
Okay tayo.
Kinsa may gusto bastaling ba butang inyo I'm going to post this screenshot in Facebook. So if you want to be part of if you want your face to be in Facebook, okay. Now William is okay. Good. Okay, show your face.
Dapat group picture.
Oh, group picture.
Attendance check.
Okay, good. Okay. Does anyone want to have your photo shown here? Don't be ashamed, guys. Okay. Good. No one else? Okay, I will take a screenshot because Carl did show a screenshot last week, and I think it was the worst screenshot I have ever seen in my life for myself.
Oh, sorry, sir.
No, just kidding. No, just kidding. No, that's kidding, because that was fun. That was fun. Okay, guys. Okay, I will take a screenshot now. Hang on. Okay, I'll finish. Oh, good. Okay, I will save. Hang on, I will save this. Okay. Oh, I think you should change your. I don't. Okay, Carl, okay, I will do again. Okay, now. Okay. Okay, I will take. I'll take a screenshot now. Okay, hang on. What? Okay. 1, 2, 3. Okay, and I will save.
Ang pogi pala ni Sir William Balawin.
Oh. Ah. I think did I did it right? Okay, here. Okay, no complaints. No complaints.
So far, no.
Okay. Good.
So far, so good.
So far, so good.
Okay, I will. I'll post this in Facebook later. Are we being that's 2. Okay. Okay, it's done. So, until here, do you have any topic in particular in which you want to learn?
Still design, sir. Reb.
I still decide. Okay.
Yeah.
Yeah. Now, because FrameCE is in design, FrameCE is automated. So if you have to design a steel, then your frame element must also be a steel. So what I need to do is change some of these elements to steel. Okay, so I will add materials, add, and then add, then W shape. Okay. Okay, and then I say change this, edit, and then change this to steel. Edit. No, yeah, that's right. Now I cannot change the element. I have to go to did load. Lyrics. Okay. Change this. Edit in properties. Maybe apply. Okay, now these 3 elements are steel. Then what I need to do is design, go to design menu, linear elastic, okay, and then select the load cases, okay, and then I will design, say for example, this member here, and click individual design. Then because it's a steel, FrameCE can detect that it's a steel element. So it will ask me, what shape should I use in the design? I have here wide flange, the E shape, the channel, or the miscellaneous channel. So I will choose wide flange. And then now it will ask me, does member have lateral support? Now this is important because in the model, FrameCE may not be able to detect if there is a lateral support or not, because sometimes you have wall which is not part of the model. So to be safe, FrameCE will ask if there is a lateral support or not. So if there is, then the unsupported length will be assumed as 0.5, just to make it almost not failing in buckling. Okay, so then after that, you have to choose what FrameCE does is that it will check all the steel sizes available in the database. So you just have to select what section you like. Say for example this one. Okay, so it says it fails. Then select another. Again, it fails. Maybe the load was too high. Okay, now it's safe. See here, so what you need to do is just select from the template and make sure that it is safe. Okay, so it's simple, as simple as that, and then accept like that. So I can also design these beams here, and then click individual design, and then this time I will assume it's a shape, and then yes. So you can see here, before it was W shape, now it's now is shape. So again, just choose a section. Okay, it's safe. So it's very easy. See here, accept, and that's it. Back to model. I don't know. Again. Okay. Yep. So I think that's it. So any question? Now again, one thing here. The steel design is using allowable stress design. It's not LRFD. Okay. So until here, any question?
Hello, sorry.
Oh, okay.
Yeah, it's Gilbert. Sir, yung maibalik ko lang yung sa analysis results. Halimbawa, yung mga corners, yung mga end corners, gagawin ko isang group 'yan. Yung mga corner columns, gagawin ko isang group 'yan. Tapos pwede ba natin sa next mga versions na makapresent tayo ng yung tabulated result niya, yung sa analysis results. Kasi yun ang pino-point out ng iba yung halimbawa para ma-present mo yung maximum moment, maximum positive moment, maximum negative moment, maximum shear, axial in a tabulated form. Kasi ang ginagawa ng iba tulad sa staad, naka-group na yun, naka-tabulated na yun, copy-paste na lang doon sa Excel para doon sa template nila ilalagay na lang doon yung stresses.
Okay. Yuri, is it similar to your question before?
More or less, sir. I think it's similar to my question.
Okay.
Before, sir.
Okay. Good.
Have you remember?
Okay.
Same question.
Okay, I will answer it again. Okay. Okay, now say for example, I will hide. Okay, hang on. I will hide the nodes. I will hide the element loads. I will hide the node numbers. Okay. Now, okay, this is for, okay, I will do it again. I will analyze this. Okay, then a moment. and then show maximum. Okay, say for example, Gilbert, hang on. If I want to show only this, I say export to Excel. Okay, then if I want to show only these two beams, did I select? Okay, then click OK. Then the output will only show the stresses of these two beams. See here? I think I only selected one, or did I? Okay, I only selected one. So again, select this. I think it's getting slow. Did I? Kurang nihinay. Okay. Now I think my computer is getting slower now. See, it's lagging. Excel, and then select this and select this, and then click OK. See here, Gilbert, only the two elements, elements 13 and 42 were tabulated. The rest were not. Is this what you want?
Okay, sir. May idea na ako.
Yeah. So then you can just, yeah. So you have the option which element to show.
Yes, sir.
Okay. So any other question? So I think we have to stop here because it's almost 9 here. Okay. So just if you have more questions, just send it to me the next time so I can answer. Because my plan is that I will make this activity like a conference wherein you can also show your problems, you can show your project, and you can share what you did, and you can ask questions to everyone, just like what I'm doing here. So this presentation was just started by myself, but I'm planning this webinar to be for everyone to present, not just for me. So, but only for those who want to volunteer. Okay. So until here, if you have no questions, I think I have to say goodbye and thank you very much, guys, for participating. And it's a pleasure to see all of you here. So it's at least we are making our. By the way, are you still in quarantine there in the Philippines?
We are in GCQ, sir. General Community